Hi everyone. So here we have the system of equations that I came up with in my earlier video of my word problem dealing with selling bananas and oranges by the pound at the farmer's market. So here's my two equations. Again, that's 3 pounds of bananas times the cost of a pound of bananas plus 3 pounds of oranges times the cost of a pound of oranges will cost you $3.75 total. Okay, 4 pounds of bananas times the cost of a pound of bananas plus 1 pound of oranges times the cost of a pound of oranges equals $2.75. So we're going to use this system to figure out the cost of bananas, a pound of bananas, and the cost of a pound of oranges. So we want to use the elimination method here. You could use a different method if you like. That's fine. But this video is just to teach the elimination method. Now, the elimination method says you want to get rid of one variable. You don't want to have two variables at the same time. Get rid of one. That'll make it easier then to go back and plug that number in and find the other variable. So I'm looking at my coefficients here, 3b and 4b, 3r and 1r. What I'm thinking is to eliminate, I need to have opposite coefficients and add them up. So the easier way to do this, in my book, is to take the second equation and multiply the whole thing by -3. That will give me a -3r there. Okay, so that's what I'm going to do. Let's take my red pen, make that a little bit thinner. Okay, so I'm going to take this equation and multiply everything by -3 on the left. There you see. And everything on the right, I'm also going to multiply by -3. I have to multiply by the same amount on both sides so that it will stay equal. All right, so this will make the second equation become -12b minus 3r equals -825. All right, and the first equation, should have that equal sign there. All right, the first equation is not going to change. We'll leave it the way it is. Oh, I should say, as I'm doing this, you notice what I did here, changing that -12 and that -3 there. I had to take this -3 and distribute it. Okay, some of us are forgetting that distributive property. It's very, very important as you go through math. Don't forget that. All right, so here we go. I'm going to scroll this over so it's closer to the camera. This is some stuff from an earlier video. All right, here's my two equations now. Okay, updated so that my R terms have opposite coefficients. And all I'm going to do is add up. Everything's lined up. That's one of the things that you look for when you want to use the elimination method. It works great if you have these standard form equations where your variables are all lined up and your constants are all lined up. If they're not, you got to get them in that form before you can start eliminating stuff. But that's a whole topic for another video. Here we're keeping it simple. All right, so 3b plus -12b adds up to -9b. 3r and -3r adds up to 0. So instead of writing 0, I could write 0, but a lot of us just like to cancel those out. They won't cancel. A lot of you are crossing things out that don't cancel. The only reason these add up to 0 is because this right here and this right here are opposites. They add up to 0. If this was some other number besides -3, it would not cancel out that +3. So make sure you've got opposites. Those cancel out now. And then these two add up to a -450. There's a decimal there. Okay. So now I've got a new equation, -9b equals -450. This is going to be so much simpler than what I started with because now there's just one variable, and this is a one-step equation at this point. I take everything on the left and everything on the right, and both of those get multiplied by -9. That's going to give me 1b equals 50. Okay, 50 cents. 50 cents per pound of bananas. If you saw my first video, that's what the answer was to the problem in the first place. But we'll go back and talk about how we check if we don't know the answer to start with. So now that I know that a pound of bananas is 50 cents from using this method, I can go back and take that 50 cents and plug it into one of these two equations. All right. I want to plug it in so that there's only one variable left, the R, the cost of a pound of oranges. So I'm going to go ahead and take that 50 cents and plug it into this one. I can plug it in the first one. It doesn't really matter, but I like that second equation because there's only one R to deal with. All right, so we're going to go 4. Well, I'll write the equation first. We said it was 4B plus 1R equals 275. All right, and we just said that a pound of bananas is 50 cents. And 4 pounds of bananas times 50 cents a pound adds up to $2. And if I want to get the R by itself, I subtract 2 on both sides. And that cancels out to 0. R equals 75 cents. So here I've got my two answers. 50 cents for a pound of bananas, 75 cents for a pound of oranges. But remember, you're not done. You've got to go back and check. You've got to make sure that these two answers fit your problem. So 3 pounds of oranges, 3 pounds of bananas at 50 cents a pound. I can just write that as 0.5, half a dollar. All right, 3 times 75 for the oranges. All right, that's $1.50 for my bananas. That's $2.25 for my oranges. And $1.50 plus $2.25 adds up to $3.75. So that's a check, right? I checked my numbers in that equation. I can check that off. Let me check now in the second one. By the way, I'm erasing it because it's a video. I'm trying to make sure everything fits on the screen. You should not erase when you check. Okay, I'm going to take now my answers and plug them into the second equation. All right, that's $2 for the bananas, 75 cents for the oranges, and 2 plus 75 cents is $2.75, right? So that checks out. So as long as my answers make both equations true, I've got the right answer. Okay, that's how you use the elimination method with 2 variables in 2 equations. Please comment if you have any questions.